So the Spectre exploit is back in the news again, and this time it's because a fairly important Linux kernel dev is claiming that hyperthreading in its current form is basically an inherent security threat. So if you're new to the channel, remember to subscribe and ding the little bell icon down below because it will really help the channel out. I'm trying to hit 100 subs by the end of the year, and we're getting closer and closer every single day. So now that's out of the way, let's get started. Good afternoon everyone, and welcome back to the channel. So today we're going to be having a look at an article by Tim Anderson on the Register. So, running on Intel, if you want security, disable hyperthreading, says Linux kernel maintainer. So this is talking about the exact same bug that came out a few years back, the Spectre bug, where basically it involves some speculative execution. I will go over what it actually is a bit later in the video, so we'll just go through this article first though. So Linux kernel dev Greg Kroah-Hartman, I'm gonna guess, reckons Intel's simultaneous multi-threading, better known as hyperthreading with Intel's implementation, should be disabled due to MDS, which is micro-architectural data sampling bugs. So Kroah-Hartman, who was speaking at the Open Source Summit in Lyons? I'm not sure where that is, has opened up on the subject before. I gave a talk last year about Spectre and how Linux reacted to it, he told the Reg. And then this year, it's about the same things he found since the last talk. It's more and more of the same types of problems. These problems are going to be with us for a very long time, and they're not going away. So this isn't the first time that someone has actually brought up this problem. The founder of, I believe, OpenBSD also talked about this, which we'll get to a bit later in the video. There's another issue though. People didn't realize how we do security updates, the whole CVE mess, and the best practices we need to have. Linux isn't less secure or more secure than anything else. The problem is these are bugs in the chips. We fix them in time, we just have to make sure that everybody updates. So ultimately, with problems like this, they're only ever going to be fixed by architectural changes on Intel, and the problem may exist on AMD's side, but it's exacerbated by some of the ways that Intel implements its form of multi-threading, basically. So Kroah-Hartman explained to attendees how these vulnerabilities exploit bugs in the hardware when the chip is trying to look into the future. So if you don't understand how Spectre works, it basically works by doing a thing called branch prediction, where it will execute code that you're likely to be executing in the near future, and through that it manages to access data that it shouldn't be able to access. Security is not my main forte, so I'm not 100% sure if that's a accurate description, but it's a short description just for this article. He added MDS is where one program can read another program's data. That's a bad thing when you're running in a shared environment such as cloud computing, even between browser tabs. So this problem wouldn't be as bad. Obviously it's bad for a personal computer situation, but because of how much of a reliance there is on cloud computing nowadays, this problem is a very serious issue, and until there are some proper architectural changes, the exploit will still exist. Whether the exploit can actually be made in real life is another question, but the exploit will still be there. So with this, you can cross virtual machine boundaries with a lot of this. MDS exploits the fact that CPUs are hyper-threaded, with multiple cores on the same die that share caches. When you share caches, you can detect what the other CPU core is doing. OpenBSD was right, he said. A year ago, they said, disable hyperthreading, there's going to be lots of problems here. They chose security over performance at an earlier stage than anyone else. Disable hyperthreading, that's the only way we can solve some of these issues. We are slowing down your workloads, sorry. So there have been some other exploits since the Spectre situation. So Kroah-Hartman, a kernel maintainer, describes some of the post-Spectre MDS examples like RIDL, Fallout, and Zombieland. You can steal data across applications, you can steal data across virtual machines, and across secure enclaves, which is really funny. Inside Intel chips, there is something called SGX, software guard extensions, where you can run code that nobody else can see. It's really porous. In the kernel, we fix this by flushing buffers every time we switch context. It solves the problem. But there is a performance hit. Flushing buffers takes time. Every single one of these mitigations to solve hardware bugs slows down your machine. So basically, these problems can be fixed in software if you're using the most up-to-date versions of the kernels and the security patches. But ultimately, these are hardware problems, and these are only guess, like really patch fixes. They are going to slow down your system no matter what software does. The extent to the software slowdown depends on the workload. If it is I/O bound, you may hardly notice, but Kroah-Hartman builds kernels. I see a slowdown of about 20%, that's real. As kernel developers, we fight for 1 or 2% speed increases, put these security things in, and we go back like a year in performance. It's sad. So Kroah-Hartman dispelled the idea that an issue like Spectre has a single fix. We are still fixing Spectre 1.0 issues almost 2 years later. It's taken a couple of thousand patches, almost 2 years. Always take the latest kernel and always take the latest BIOS update. Okay, so if you're not using a supported distro or a stable long-term kernel, you have an insecure system. It's that simple. All those embedded devices out there that are not updated, totally easy to break. If you're running in a secure environment and you trust your applications and you trust your users, then get the speed back. Otherwise, running in a shared environment, running untrusted code, you need to be secure. So what he's basically saying here is that on a personal system, you may be fine because you are not a serious target, but for these embedded systems and for cloud computing environments, the fact that this exploit still exists is very serious. So if you are running a system where you are only ever running trusted code, which even on a personal system, you can't really say you're doing because of the fact that Spectre exploits and Spectre-like exploits can be done through JavaScript. So if you have JavaScript enabled in your browser, then you are still likely to be hit by an exploit like this, or at least it's still possible to hit you with an exploit like this. Whether it's likely is another question altogether. So we'll just briefly go on to explain what Spectre and Meltdown are. Meltdown's not important to this story, but we'll just go over what they basically are. So Spectre and Meltdown are the names given to two different varieties of the same fundamental underlying vulnerability that affects nearly every computer chip manufactured in the last 20 years. So all of the variants of this underlying vulnerability involve a malicious program gaining access to data that it shouldn't have the right to see, and do so by exploiting two important techniques used to speed up computer chips called speculative execution and caching. So I'm not going to read all of this article by, who's it by? CSO by Josh Frulinger. So as always, I'll put all the links to these articles in the description down below if you want to check them out for yourself. So speculative execution essentially involves the chip attempting to predict the future in order to work faster. If the chip knows that a program involves multiple logical branches, so every time you have an if statement, that is a different branch in your code. It will start working out the math for all of those branches before the program has to decide between them. For example, if a program says, if A is true, compute function X. If A is false, compute function Y. The chip can start computing both X and Y in parallel before it even knows whether A is true or false. So this does have a serious speed boost, but the problem is that you're going to be accessing shared data with code that may not actually be running, and that can actually end up giving a security fault, I guess. So caching is a technique used to speed up memory access. It takes a relatively long time for the CPU to fetch data from RAM, which lives on a separate chip. So there's a small amount of memory storage called CPU cache that lives on the CPU chip itself, and that can be used to access very quickly. So just a quick rundown of how computers work. So you have your main storage, that's your like hard drive, your SSD. Then you have your RAM, that is just your general RAM. Then on your CPU, you have, typically these days, you have 3 levels of cache. You have your L3, your L2, and your L1 cache. I believe the L1 is the quickest. L3 is the slowest, and then L1 is the quickest. So there are these 3 levels of cache. So basically what happens with Spectre is that you can use this exploit to make the CPU reveal data that it shouldn't be revealing because of these different branches that can be executed. I'm not 100% sure on how this would actually work in a realistic context, but it is something that could potentially occur. I don't know if there have actually been any successful attacks using this exploit though. So this last article we're going to go over is called Is Hyperthreading a Fundamental Security Risk? From Extreme Tech by Joel Hruska, I'm going to guess? We're not going to read this article, but last year, Theodor Rad? What? These names are hard to say. The founder of OpenBSD argues that hyperthreading can no longer be trusted and should be disabled by default. Extreme Tech reached out to Dorad to discuss the issue and why he and other developers in the open source community are concerned about the security risks of hyperthreading. So we're not actually going to read all of this. What I came to this article for was this part down here. So as we've previously discussed, Spectre, Meltdown, and Foreshadow, which is another exploit that exists, are all flaws that exploit certain behavior of Intel CPUs, also AMD CPUs, but because of the way that Intel handles it, they are exacerbated on their CPUs. In when they speculatively execute instructions, while speculative execution, I really hate that word, is a long-standing and proven technique for improving CPU performance, Dorad identifies 3 distinct issues that have combined to create these problems. He writes, Intel CPUs fetch and decode and execute instructions including their data loads without doing any security checks, then unwind them if they are wrong after the fact. CPUs from other vendors have experienced minor Spectre problems, but Intel takes it to a whole new level. So the way that Intel gets so much performance out of their CPUs is by ignoring a lot of these security checks. Other CPUs do it, but the way that Intel handles it, judging by what's being said here, is just taken to a whole nother level. Since they don't do any security checks up front and tie their L1D, which is the level 1 data cache, to their TLB, which is the translation look-aside buffer, which is basically the buffer that stores your speculative execution, Intel has a really astounding "where did a cache line come from? We don't care" error in the L1D cache, which results in data in a cache line from a different privilege domain becoming visible to speculative instructions, which creates a further Spectre problem. So basically what he's saying here is that you can have, say, a admin privilege application and a user privilege application sharing the same bit of memory. So theoretically, the user privilege application could access the admin process's data, and that is a very serious security issue. The same speculation without security checks applies to registers. Intel didn't even check if the FPU is enabled. So the FPU is the floating point unit. That is the part of the CPU that does calculations with floating point numbers before accessing FPU registers. So they really didn't do any security checks before running any instruction. All decisions are made at the end. That means all instruction sequences have Spectre side effects, and we simply are waiting for people to find worse consequences and publish them. So as of the time of writing this article a year ago, OpenBSD was the only operating system that had come out and said that disabling hyperthreading altogether was a good idea. But Intel has stated that they don't think this is the case and that software fixes will be enough to actually handle this. So I'm not going to read this out, but there is a bit of an XKCD here that talks about the problem with speculative execution and its context in the cloud. So as I mentioned earlier, security isn't my forte, so I'm not 100% sure on whether what the OpenBSD guys or what the Linux guys are saying is accurate or what Intel is saying is accurate. Honestly, Intel is probably trying to defend their bottom line, but I don't know who is actually telling the truth in this situation. Maybe they've both got a bit of truth in their arguments. I don't know how likely a Spectre attack is in real life. I haven't done that much research on the problem myself. I just understand, I guess, how this problem can exist. So if anyone actually has any resources about how this exploit could actually take place in real life, then let me know in the comment section down below and I'll have a read through them and maybe also make a bit of a change to this video afterwards or upload another one later. So I think that's pretty much everything for this video. So if you like this video, remember to smash that like button and leave me a comment down below letting me know what you think. As I said, if you got any resources that'll let me know actually what's happening that I don't actually keep track of with this problem, like how Spectre could actually be exploited in real life, let me know and I'll check them out. If you want to see more random news articles like this, then let me know about them on Twitter or in the comment section. I'll check them out, and if they interest me, then I might do another video on them. So if you want to see those videos when they come out, remember to subscribe and ding the little bell icon down below and you'll probably get updates. But as always, YouTube can never be trusted to actually push updates to anyone, so also go follow my Twitter and my Mastodon and you'll probably get updates there. So as you can see, I've got my microphone in the corner of my screen. I have my laptop really far away, so I kind of had to do that to get good audio. If it's not bothering anyone, I might start doing it because it'll make it a bit easier to get like better audio, I guess. So I think that's pretty much everything for me, and I'm out.